Hello my friend, welcome to my channel. So today we are going to look at absolute maximum or minimum of a function. So we can say if you take a point on the domain, let's say x equals c, then f of c is greater than or equals f of x for all x on the domain. So then we can say this at x equals c, there's an absolute maximum of the function, right? For example, let's say this one. So this is the quadratic function. So as you can see, if you consider this point, this is 2, 3, right? So f of 2 equals 3. So my x equals, now c equals my 2, right? So c equals 2 in this case. So my function value is 3. So we are going to compare all the y values of this function with this 3, right? For example, if you take this point, right? As you can see, the y value is 2, which is less than 3, right? So that satisfies this one, right? Because 3 f of 2, which is 3, is less than, 3 is greater than or equal f of, at this point let's take it's 3, f of 3 equals 2, right? Because 2 is less than or equals 3. So this condition is satisfied at this point. So likewise, if you consider any point on this graph, the y value is less than 3, right? So if you see that condition on your graph, then we can say this point, at this point, so at x equals 2, there's an absolute maximum for this function. So the absolute maximum in this case is 3. The y value is 3, right? So if you look at this one, this is another parabola shape, right? So let's look at a point on the domain x equals c. If f of c less than or equals f of x for all x on the domain, then we can say there is an absolute minimum on this graph, right? Let's look at this point. So the coordinate of this point is 1, negative 3. So that is f of 1 equals negative 3. So x equals 1 is my c now, like this, right? So we are going to compare my f of 1 with all other f of x, right? So let's take 2, x equals 2. So you know my y value is negative 2, right? So I'm going to compare f of 1 with f of 2. So f of 1 is less than or equal, let's say it like this, negative 2, right? So if you consider any point on this graph, you can see that the y value of at each of these points is greater than negative 3, right? So this condition is satisfied. So if you see that kind of a behavior on your graph, then you can definitely say that this point is a absolute minimum for all x, okay? Make sure this condition is satisfied for all x, right? So the absolute minimum is negative 3. So absolute minimum is at x equals 1 and absolute minimum is negative 3, the y value, okay? So let's see an example. So here I have two examples. If you look at this graph, and the next thing is the local minimum or maximum. Let's talk about that one first and then let's look at the graph, right? What is a local minimum? If let's say x equals c is a local minimum, right, or the relative minimum, then you will see this one, right? F of c less than or equals f of x when x is near C. Okay, near C, not for all x on the domain. We are looking at all the x values near C, right? So then we can say it's a local minimum. Okay, so if x equals C, right, at this point, if you see this condition, f of C greater than or equals f of x, when x is near C, not for all x, right? For all x is in the absolute maximum or minimum, but in this case it is local, so we have to look at small area, right? This is important. X is near C, then we have a local maximum. Okay, so let's look at these graphs. Now we know absolute maximum, minimum, local maximum and minimum, right? Let's look at this graph. So I'm going to select this point. What can you say about this point? So at x equals 1, what can you say? Is this a local? So you can see it's in this side, right? So that means it's a maximum, but is it local or is it absolute? How do you verify that? To verify that, you have to look at this one. So if it is absolute maximum, then you cannot have y values greater than 1, right? But if you consider this point, it is greater than 1, right? So this cannot be an absolute maximum, right? So let's look at the local maximum. If you consider a small area like this around x equals 1, then you can see that this one, right? For all x, you can see if you consider this point, the y value is less than 1, right? So if you consider a small the point over here, the y value is less than 1, right? So this condition is satisfied. So therefore we can say this one is local maximum, right? It cannot be a absolute maximum. Why? If you consider this point, the y value is greater than this one, so it cannot be an absolute maximum, because for all x this one should be greater than, right? If you consider this one, what can you say? This can be a minimum, but is it local or absolute? Let's look at the absolute condition. So if you can see, this is the y value is -1. If it is an absolute minimum, then what happens? For all x, the function value should be greater than this value, right? But what can you say about this one, this point? The y value is less than -1. So this cannot be an absolute minimum, right? So this can be a local minimum, because if you consider a small area around 3, then this point is greater than, the y value at this point is greater than the -1, and also here y value is greater than this this point, -1, right? So this one is local minimum. Okay, so what about this one? Is it local or absolute? If you see, the y value is -2 at this point, right? So whatever the point you select, the y value is greater than -2. Over here, here, anywhere, right? The y value is greater than -2. So then this can be a absolute minimum, right? This is absolute minimum. So what about the absolute maximum in this case? We don't see any absolute maximum because the function increasing. So we cannot find a absolute maximum point in this graph, right? So we can say no absolute maximum here, because always you can find some point where the y value is greater than that point y value. Okay, so this one is increasing up to positive infinity, and this side also goes to positive infinity, so we cannot find an absolute maximum in this graph. How about this one? Let's identify local maximum, minimum, or absolute maximum or minimum, right? Let's look at this one. So this is a maximum, but is it local or absolute? If it is absolute, then let's take this one. The y value is 1.5. At x equals 2.5, the y value is 1.5, right? So if you consider this point, y value is greater than 1.5, right? So that the absolute maximum condition is violated. So that's why this is not an absolute maximum, but this can be an local minimum. Sorry, local maximum. So this is a local maximum, right? This is local maximum because of this part. Because of this part, right? The y values are greater than this 1.5. And how about this one? Is this an absolute minimum or local minimum? So if it is an absolute minimum, right? So what can you see? So this cannot be an absolute minimum because your y value is -3, but you see some values less than -3, right? There are some values over here, so this cannot be an absolute minimum. So this can be a local minimum. Okay, this point is local minimum. What about this one? It's a maximum. Is it local or absolute? So if you see, the y value at this point is over here. Let's say it's 4, right? -1, 4, right? So y value is 4. So do you see any other points that the y value is greater than 4? So no graph over here, right? From this level, right? You don't see any y value. So this is an absolute maximum. Okay. How about absolute minimum? The function is increasing up to -infinity, and this side also -infinity. Because if you select any point, then you can the y value at that point is greater than another point you can find, because this function is decreasing, always decreasing. So you cannot find an absolute minimum in this case, right? So no absolute minimum. Okay, I hope you understand this one. If you have any questions, you can comment, and thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Thank you so much. Bye.